Hello everyone, I'm Vaishnavi from grade 11 LMS. So today I will be teaching you all on chemical reactions and equations from grade 10, chapter 1 chemistry. And this video is part 2. Whoever didn't watch part 1, please do watch and then come back to part 2. So let's start. Different types of reaction. So there are many reactions which we'll be learning in this video. So the first one is combination reaction. Reaction in which two or more reactants combine to form one product are called as combination. So as we learned in the earlier video, reactants means the uh, elements that are reacting to form a product. So product is on the right hand side part and reactants are on the left hand side part. So the general combination reaction can be represented by the chemical equation given here. So like if the elements are not mentioned over there, the simple way to represent this combination reaction is A is an element which is reacting with B, like combining with B to give AB. So this is the reaction that you can write in general form. So we'll take examples for this and go further. When magnesium is burnt in air, magnesium oxide is formed. In this reaction, magnesium is combined with oxygen. So here they're trying to tell magnesium is reacted with oxygen to form magnesium oxide. So over here, this is magnesium is A, oxygen is B, and the product that is formed is AB. So that's what they're trying to tell over here. Next example is when carbon is burnt in oxygen, carbon dioxide is formed. In this reaction, carbon is combined with oxygen. So here carbon plus oxygen gives carbon dioxide. As I told you in the previous video, there are some short forms like to make the equation more informative. Now you can see those things like G, S, and all added. So this is why they use it to tell that which physical state the particular element is in. So yeah. Coming back to the point, so here carbon is reacted with oxygen to give carbon dioxide. Over here carbon is element A, oxygen is element B, and which both combining together give AB, which is the product. Decomposition reaction. So this decomposition reaction is quite opposite to combination reaction. Over here decomposition reaction is like as you see AB gives A plus B. It decomposes and gives A plus B. But in combination it's quite opposite. Two elements combine together to form a product. So it's like when you compare you can see that it's quite opposite. So let's read out this point and try to understand what it says. Reaction in which one compound decomposes into two or more compounds or elements is known as decomposition reaction. A decomposition reaction is just the opposite of combination reaction. As I just now told the same points, they're just telling the same thing over here. So now let's see an example and understand it further. When calcium carbonate is heated, it decomposes into calcium oxide and carbon dioxide. So this point is telling that calcium carbonate, which is CaCO3, like it decomposes to form CaO, which is calcium oxide, and CO2, which is carbon dioxide. So under decomposition, there are three different parts, which is thermal decomposition, photoelectric decomposition, and electrolytic decomposition. Let's see one by one. So first one is thermal decomposition. Thermal means in general heat, something related to heat. So in the presence of heat, this reaction takes place. So the decomposition of substance on heating is known as thermal decomposition. So let's see an example. So lead nitrate, uh, okay, PbNO3 twice on in the presence of heat gives PbO plus NO2 plus O2. So giving heat, it forms lead oxide plus nitrogen dioxide plus oxygen. So these are the products that are obtained over here. So next is Electrolytic decomposition. So in this, the reaction in which compounds decomposes into simpler compounds because of passing of electricity is known as electrolytic decomposition. Now, listening to the word electrolytic itself, you can understand something related to electricity. So this reaction takes place in the presence of electric current. So let's see the example. When electricity is passed in water, it decomposes into hydrogen and oxygen. So when electricity is passed in water, it decomposes and divides into hydrogen and oxygen. Next is photolysis or photo decomposition reaction. So this process is also known as black and white photography. So over here it's telling reaction in which a compound decomposes because of sunlight are known as photolysis or photodecomposition reaction. So this reaction happens in the presence of sunlight. So let's see an example. When silver chloride is put in sunlight, it decomposes into silver metal and chlorine gas. So another example of this is this silver bromide, which is nothing but AgBr. On reacting with sunlight, it gives Ag to Ag plus Br2. So the equation is balanced. So yeah, let's go to the next one. Next is displacement reaction. The chemical reaction in which a more reactive element displaces a less reactive element from a compound is known as displacement reaction. So as I taught you in a video, the reactivity series of the elements, like comparing with that, now you're gonna use it in this reaction. So as we learned the reactivity series, it's telling that the more reactive elements are more dominant, like they will be the strongest. So they displace the less reactive, like the weak ones. Like take an example, if you have a sibling who is younger to you and you are stronger than them and you guys are fighting for a remote to watch TV. So obviously the one who is older will be able to defeat the younger one in grabbing the remote. So you can remember it like that. More reactive is the elder one and less reactive is the younger sibling. So obviously it will replace. So that's what they're telling. More reactive or dominant element will uh, displace the less reactive element. This process is known as displacement reaction. So the general form of this reaction is A, A reacts with BC, which gives AC plus B. You might not understand, just remember this. I will tell examples so you'll understand how to do this. So let's take this example. When zinc reacts with hydrochloric acid, it gives hydrogen gas and zinc chloride. So let's see the reaction. Zinc is here and HCl, which is hydrochloric acid. When it reacts, it displaces. Now zinc is more reactive than hydrogen. So zinc takes the place of hydrogen. Now zinc is taking the place of hydrogen. So that's why you see zinc chloride and hydrogen taken out. And it's left all alone. Okay, if you still didn't understand, let's take another example. So in this example, zinc plus copper sulfate gives zinc sulfate plus copper. So here zinc is more reactive than copper. So that's why zinc is replacing instead of copper and copper is kicked out. Like it's left alone. So yeah, over here it is replacing and that's how you get zinc sulfate and copper. Next is the double displacement reaction. So this is kind of similar to displacement reaction. So let's see. Reaction in which ions are exchanged between two reactants forming new compounds are called double displacement reaction. So the general form to represent this equation is reaction is AB plus CD gives AC plus BD. So it's like B and C are getting interchanged. They're getting changed up. So let's see an example. When the solution of barium chloride reacts with the solution of sodium sulfate, White precipitate of barium sulfate is formed along with the sodium chloride. So let's see this reaction. BaCl2 plus Na2CO4 gives BaSO4 plus NaCl. So here double displacement reaction in which precipitate is formed. So the precipitate is BaSO4. It is also known as precipitation reaction. So it's also known as neutralization reaction also, which means like it gets neutralized. Acid plus base gives salt. So it gets neutralized. Now we'll be learning about the precipitation reaction and neutralization reaction. So yeah, what is precipitation reaction? The reaction in which precipitate is formed by mixing of the aqueous solution of two salts is called precipitation reaction. So precipitate is nothing but some residue that is left over in the reaction when two compounds are reacted. So let's see an equation. Na2SO4 is sodium sulfate on reacting with barium chloride, which is BaCl2, gives BaSO4, which is barium sulfate, which is the white precipitate, the leftover residue which is there, plus NaCl, which is nothing but sodium chloride or common salt. So this is the precipitation reaction that occurs. There will be a precipitate on reacting with two compounds. This doesn't happen in all the reactions but only for particular ones. So next is neutralization reaction. Neutralization means you can understand like neither bad, neither good, like that, like moderate in between. So that's what neutral means. So there is a reaction based on it, which is the reaction in which an acid reacts with a base to form salt and water by an exchange of ions is called neutralization reaction. So this point tells that when an acid reacts with a base, it forms salt and water. This by the exchange of ions, like when the ions are exchanged, that time this neutralization reaction occurs. So let's see an equation. HCl plus NaOH gives H2O plus NaCl. So it got neutralized. Next is the redox reaction. Redox reaction is nothing but the chemical reaction in which both oxidation and reduction takes place simultaneously. So first, to know what is redox reaction, you must know what is oxidation and reduction. Oxidation is nothing but like hearing the word oxidation, you can understand oxygen is added. Like some word related to oxygen is there. So it's nothing but reaction that involves gain of oxygen. Oxidation means gain of oxygen. That's the key point you have to remember. And loss of hydrogen. It's fine even though you don't remember because automatically you'll remember it. Reduction is like something is getting reduced. So over here we are doing in the comparison of oxygen. So over here oxidation means gain of oxygen and reduction means loss of oxygen. So yeah, over here there is an equation which shows. So zinc oxide plus carbon gives zinc plus carbon monoxide. So zinc oxide is reduced to zinc, which is reduction. So oxygen is lost over here. And carbon is oxidized to form carbon monoxide. So over here carbon is oxidized as there is a oxygen element added to it. So now redox reaction is nothing but the mixture of both oxidation and reduction reaction. So now you see this example CuO, which is copper oxide plus hydrogen gas give copper plus water. So here copper oxide is getting reduced to copper where oxygen is removed and hydrogen is getting added with, like it's getting oxidized, which means it's gaining an oxygen atom. So like both together, like both are involved, right? So here oxygen is getting added, which means oxidation, and there is a reduction of oxygen as well. So both are getting like both are happening in the same reaction. This reaction is known as redox reaction. Now we'll learn what is oxidizing agent. Oxidizing agent is nothing but the substance which gives oxygen for oxidation is called oxidizing agent. So you might be confused with this. So you just remember reduction and oxidizing agent are the same. Like reduction is loss of oxygen and oxidizing agent is also loss of oxygen. A substance which removes hydrogen is also called oxidizing agent. Like oxidizing agent is nothing but removal of any of the atom, like either oxygen or else hydrogen. Removal of any of these two atom elements is called oxidizing agent. And reducing agent is nothing but uh, the substance which gives hydrogen for reduction, and the substance which removes oxygen is also called reducing agent. So oxidation and reducing agent are the same. Oxidation is gaining of oxygen. Like reducing is also like gaining of some element of hydrogen or oxygen. So easy way is reduction is equal to oxidizing agent, and reducing agent is equal to oxidation. If you remember this, then it is easy. Next, different types of reactions. So under this, there are still more. Exothermic. I know that you all must have been learning this. So oxidizing agent reaction, exothermic reaction means something that involves heat. Like there is evolution of heat, like heat is emitted out in the process of this reaction. So over here, as you see, carbon plus oxygen gives carbon dioxide plus heat. Heat is emitted while this reaction takes place. Endothermic means heat is involved, like it requires heat to take the reaction. Like to react, it needs heat. So over here, ZnCO3 plus heat gives ZnO plus CO2. So that is endothermic. For endothermic, you can say evaporation also. Evaporation, I mean not evaporation, photosynthesis. So photosynthesis during that reaction, it needs heat from the sun. And for exothermic, you can take respiration. While respiring, you emit out some amount of heat. Now, effects of oxidation reaction in our daily lives, like what happens in our daily life, like where is it used, what does it affect? So the things that affect are corrosion. It is an undesirable change that occurs in metals when they are attacked by moisture, air, or acid and base. So corrosion is like when a metal is reacted with the atmosphere, there will be obviously air and moisture that will be attacking on these metals. So they start changing their behavior, like the way they are, they won't be like that. There will be some oxide layer formed on it, like rusting of iron. So over here it becomes into iron oxide. So there will be that rusting kind of color coming. And rancidity, undesirable change that occurs in oil containing foods due to the oxidation of fatty acids. So this rancidity means like spoiling of oily food. Like take an example, you ate some lace and you couldn't eat anymore, so you left it open. And after some time when you see, it will be like smelling and it will start becoming like very soft it becomes, right? So that is when rancidity has happened to the food. So to prevent that rancidity to happen, you have to like to prevent it, you have to do something like adding antioxidants to the food material, storing food in airtight container like in Ziploc bags and stuff, and flushing out nitrogen gas and refrigerating it. So either you have to put it in the freezer, like in the fridge, or else you put it in some airtight container where air doesn't goes into the particular uh, packet or something. And as you know, when the layers are getting manufactured and coming to you, you can see most air and less of the lace. This is because to prevent the rancidation. So the nitrogen gas is flushed into the packets. So there won't be further oxidation process happening. Hope you all understood this concept, and if you didn't, please do let me know whatever your doubts are. Please be free to ask whatever you have. And thank you. Meet you all in the next video.